Good morning, seventh grade. So let's go ahead and let's get started with today's lesson. This is going to be the final one in this chapter. So we're going to go ahead and we're going to finish up this lesson today, do a quick little review toward the end of the week, and then next week you guys are going to be given your first e-test, so your first test online, okay? So we'll talk a little bit more about that at the end of the week when we do our review video. But let's get started with today. So chapter 7, lesson 7, simulate compound events, okay? And remember, compound events, two or more things happening. Now, whenever we do this lesson, there is a vocab word I want you to know, and that is simulation. And a simulation is a model for a real-world situation that can be used for probabilities. And I'm going to show you an example of a simulation here at the bottom of this problem. All right, so let's go ahead and let's get started with number 1. So it says Allie is planning a hike. And Allie, like most people, does not like to hike in the rain. There is a 40% chance of rain Thursday, Friday, and Saturday. So guys, with these problems, want you to realize there is a lot of it that's given to you, and you can see that in your book in chapter 7, lesson 7. Okay, I'm copying these straight from the book, and again, a lot of this information is given, so don't panic over it just quite yet. Okay, now with that being said, 40%, that's the percent chance that it has of raining these 3 days, Thursday, Friday, and Saturday. I know that 40%, if I turn it into a fraction, is 4/10. And I can simplify 4/10 into 2/5. Okay? So, with that being said, I can create a method finding probability for this problem. And on most of these problems, guys, they're going to show you kind of like a spinner, per se. So I'm going to go ahead and draw a spinner, and my spinner is going to have 5 parts. And let's just kind of make it the best we can with 5 equally sized parts on it. Now, this 2 represents rain. It's going to rain 40% of the time. So 4 times out of 10 it would rain. So 2 times out of 5 it's going to rain. So I'm going to say rain. This will be rain. And then the rest of them are going to be no rain. Now, with this problem, and with many of the ones that they give you, you're going to have to kind of do some decoding. It's almost like you're a scientist in this chapter or this lesson. It's very much looking at something and having to kind of figure out the code that's given. Now, Allie got real mathematical here. She knew there was a 40% chance of rain. She made this awesome spinner that had 5 sections on it. She showed that 2 of the 5 sections there was going to be rain. And Allie wanted to know, okay, my question, guys, with this problem is, should Allie go on the hike? And remember, she doesn't like to hike in the rain. So this is kind of a question, this is kind of like a question we would ask ourselves in the real world, because a lot of us don't want to do things in the rain. So what's the weather look like? So Allie went through and she made this spinner, and she did 5 different trials. And these trials represent 3 days. So on the first trial, whenever she spun her spinner, she found that it would rain the first day, not rain the second day, and not rain the third day. On her second trial, she found that it would not rain, rain, and then not rain. And you can go through and kind of see, guys, what trials 3 through 5 look like through my chart as well. And again, I don't want you to panic on these because this information is going to be given on every one of your problems. You're going to be given the original problem, you're going to be given what the spinner looks like, then you're also going to be given the trials that were done, okay? And this lesson focuses on looking at these situations and kind of looking at the data and saying, okay, what can I tell from the data? So should Allie go hiking based on the probability that she found? And this, guys, is what we call a simulation. This is a model that can be used about the real world, which it is, for probability. And these are the different probabilities that she found in her 5 different trials. So based on our data here, should Allie go hiking? What do you think? Yes or no? I'm going to say, should she go hiking? Yes. I think Allie should go hiking. But I want to know why. Why do I think so? And my reasoning for why she should go hiking is that based on the simulation, yes, she should go hiking. Because based on the simulation, or based on the model, it will only rain one of the 3 days. So I'm going to say that, yeah, Allie should go hiking because it's only going to rain on one of the 3 days. So she's got a pretty good shot of having 2 clear days to hike on. And notice, if you look at your data here, trial 1, only 1 rainy day. Trial 2, only 1 rainy day. Trial 3, now this time, guys, there were 2 rainy days, but on trial 4, there was none. So it's almost kind of like one of these rainy days could be placed on 4. And the same thing on 5, guys. There's only 1 rainy day. So there's only 1 rainy day, it looks like there's going to be, while Allie is out hiking. Now, some of you might be thinking, Mr. Garrett, I can make a convincing argument for no. And maybe your argument for no is that with this model, you're not sure what day it's going to rain on, and you know it's going to rain on one of the days. So that would be your reason for no. And I would probably accept that answer as well. So you could really kind of persuade either way here, but I need to know why. So again, we're looking at our models here. We're looking at those probabilities that go along with those simulations. And we're talking about, okay, should someone do something, or is that probability likely or not? Let's go ahead and let's look ahead. Let's look at another problem. Let's look at number 2. So this time it says a baseball team has a 50% chance of winning one of its next 4 games. And I show that through my simulation where 1 represents win, 2 represents loss, and that's used to show the simulated probability. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9. There was 10 different trials that were done. On your trials, they used a spinner where one side had win and another side had loss on it. This team played 4 games, so each trial had 4 different results of either a win or a loss. Remember, 1 represent wins, 2 represents losses. So for trial 1, it showed a win, loss, loss, win. For the second trial, it was a win, win, loss, win. Same thing with trial 3. I'm just looking at, guys, what 2 corresponds with and what 1 corresponds with. So on trial 3, we'd have loss, loss, win, win. And my question here is, of the next 10 trials, how many of them had a favorable outcome? And with that being said, a favorable outcome for this particular question. Remember, we wanted the baseball team to win 50%. So of the 4 games, which ones of these showed exactly 50% winning? That's my favorable outcome here. How many of my trials had exactly 50% winning? So if I have 4 games, how many of those 4 should be a 1? That should be 2. So I should see 2 1s for it to be favorable. So notice on trial 1, guys, there's 2 wins and 2 losses. So that means they won 50% of the time. Notice on number 2 here, trial 2, they won 3 times and they lost once. It's not favorable because they won more than 50%. So that would be a no. So I'm going to go through here. I'm going to find all of them that I see a 1 come up 2 times. There we have a 1 twice. And we also have a 1 twice right here. So of the 10 trials, 4 were favorable. And we could then represent that with a fraction or even a percent. 4 tenths or 40% then. So guys, this is what we're looking at today. And we're not going to do too many examples of these types of questions because I really don't want to focus too much on this lesson. I think we do need to know how to do these simulations. But I want the majority of what we're focusing on to be from lessons 1 through 6. But the whole concept behind this is being able to take these simulations and being able to decode them. And I'm less worried about answering the questions as far as being able to understand, okay, this is not really happening. This is a simulation, so it's almost like if it were to happen. And also being able to understand what these numbers represent. Okay, if I read my question, anytime I see a 1, that's a win, 2 is a loss. So this trial, they resulted in a win, loss, loss, win. So I'm wanting you to be able to understand how to read these simulation maps as well. Guys, if you have any questions over our notes, please let me know. Otherwise, we will get moving along more with this lesson on Wednesday. See you guys.